Okay, so today we are going to talk about exponents, and we've used exponents before, but we're going to sort of use them in some new ways. So exponents are just a shortcut for writing repeated multiplication. So when we see something like x cubed, that means x times x times x, right? Obviously, x cubed is a shorter way to write that. 2 to the 5th means 2 times 2 times 2 times 2 times 2, right? Obviously, 2 times 2 times 2 times 2 times 2, 5 times there is very different than 2 times 5, right? 2 times 5 is 10. 2 to the 5th is 32. Okay? So exponents allow us to take these big things and compress them down. So here I have 4 times itself 3 times. That's 4 to the 3rd. And y times itself 1, 2, 3, 4, 5, 6 times. And so I get y to the 6th. The next one shows what happens when we have exponents in fractions. And so we can write out what the exponents mean and then use the stuff that we were doing in chapter 10. So there's x to the 5th and then x squared. And so we can use the stuff that we were doing in chapter 10 to say, well, these things are identical. We can cross them out. And so this x crosses out with this x, and this x crosses out with this x, right? And so all I'm left with is 3 x's on the top. And so that's the same as x cubed. Next one is when we have a power outside our parentheses. And so we just write out what exponents mean. When we're cubing something, it means multiply that thing by itself 3 times. All right? And so what's a way I could simplify this a little bit? Well, I have 3 4s, right? And so that's 4 to the 3rd. And then I have x squared, which is x times x squared, which is x times x, and x squared again. And so all together, I have 6 x's. So I have x to the 6th, right? So just different ways of writing the same thing. And all these examples up here basically lead us into a few properties. And so the first property is what happens when you're multiplying powers like this. And that's basically what we just saw here. When we have x squared times x squared times x squared, we're basically just adding up those exponents. I had 2 here, 2 here, 2 here. I ended up with 6. And so in general, when you have x to the m times x to the n, you end up with x to the m plus n. You're adding in that exponent, adding in the exponent. Dividing powers, we saw that up in example 4, right? Basically, when you have the same thing in top and bottom, you can cancel a bunch out in whichever number is lower here. So I can cancel out these 2 with 2 on the top, and I'm left with 3. And so we're going to switch to subtraction now. And so if you have x to the m divided by x to the n, you subtract those exponents. So notice how these sort of go together. Multiply leads to adding, dividing leads to subtracting. Right? So you just have to remember those. Think about how the exponents work. Power to a power, this is where, notice the difference. People get this and the first one mixed up. Notice this one down at the bottom just has the 1x. It's to the m and then to the n again. And what you do in that case is you multiply the powers. And so the new power is m times n. And basically the reason for that is because you have n of these things, n x to the m's. And so when you have a bunch of x to the m's multiplied out n times, right, the short way to write that is just multiply m by n. Okay? And we can sort of see that shortcut up here, x to the 2nd to the 3rd. The shortcut is just to multiply those 2 powers and get x to the 6th. Okay? And so let's do a few examples now. And then we'll try some practice as a class. So this is the first property. Both bases are the same. I simply add those exponents. I have a total of 29 x's. Just remember the bases have to be the same before you can combine them. So here I have 8 x's and 12 y's, right? And you can't combine these anymore because the bases are different. Okay, so I just stop there. Next one is division. Division leads to subtraction. And so I do 40 minus 15. So I get x to the 25th. X to the 25th. For the next one, the 10 over the 5, that's just like a fraction, 10 fifths. Well, that's just 2, right? 10 divided by 5 is 2, has nothing to do with the exponents. The next one has exponents, 12 and 6, and so I subtract, right? So 12 minus 6 is 6. So I end up with 2x to the 6th. Okay? And again, the reason that happens with the x's is basically those x's are canceling, right? Those x's are canceling. Last couple, x to the 4th to the 5th. That's property 3, power of a power, and all we do there is multiply. So we get x to the 20th. This last one is a little tricky. That 4th power goes to all the things, and so I'm going to have 2 to the 4th, sort of like the distributive property. X to the 3rd to the 4th, and y to the 2nd to the 4th. Right? So that's sort of the first step. Now I'm going to figure out 2 to the 4th, so that's 2 times itself 4 times. So 2, 4, 8, 16, so that 2 to the 4th becomes 16. And then it's the power to the power rule twice. So 3 times 4 is 12, and 2 times 4 is 8. So that's the simplified version of that first one. So hopefully that makes sense, and we'll do a few practice problems together now.